I am Simon Stewart. I was the lead of the Selenium project. I created WebDriver. I did every Selenium release from 1.0 all the way up to 4.0, which was like a decade and a half. It was a long time doing open source. So I know something about flaky tests, because have any of you used Selenium before? Right. And have you all got rock solid test suites that I never did? Excellent. It can be done. It should be done. I don't know why people have a problem. I believe the kids say it's a skill issue. I don't know. I'm currently a software engineer at Block, working as part of the DX team, as a developer experience. My focus primarily is on build and build tools, but part of that is looking after CI. So this is very relevant to what I do in my day job. You will notice a theme with the pictures in this deck. You will also notice a point where I stopped looking for things that looked flaky and just started looking for things that looked delicious. So do let me know when you spot that. And I think when we're talking about flaky tests, it's really useful for us to have like a concrete definition of what that is. So what do we mean by a flaky test? Well, what are the qualities of a good test? The first quality is it's self-checking. That is, it doesn't need a human being to verify whether or not it worked, like when there's endless pipelines, which you need some poor person sitting in a cupboard somewhere to go, I guess that's good. The second thing that it needs is it needs to be fast. By that I mean, it needs to give feedback as quickly as possible. It doesn't actually need to run in milliseconds, although that is what we would like, but it needs to be as quick as possible. One of the best ways to allow us to get that feedback quickly is if a test is isolated. That is, if it can run in parallel with other tests at the same time. Who's got a mobile phone? We all do. These things have like 4 cores in them, 4 CPUs, can do 4 things simultaneously or more. It's unbelievable. Like when I started computing, we had 1 CPU. We thought it was really impressive when we had 2, and now in my pocket, I have more computing power than God. It is unbelievable. Our machines can run more than 1 test at a time. But we need to write our tests in order to be able to support that. Our tests need to be isolated. And finally, our test, a good test, needs to be repeatable. That is, it should effectively be idempotent. You can run it again and again and again and again, and it will give you the same result every single time. And it's that again and again and again that is actually the underlying source of flakiness. When you run a test and it gives a different result every time, we call that flaky. That's how we identify it. What are the underlying causes of flakiness? I mean, if you've used Selenium, or indeed Playwright, or indeed anything, one of the classic causes of flakiness is timing issues. Oh, I didn't wait long enough. Oh, I waited too long, and now something has timed out. No, there is a race condition. It's all terrible. I don't know what I'm going to do. Timing issues. That's a classic cause of flakiness. If we're using anything using a modern architecture, a database, microservices, macro services, right-size services, a monolith that people connect to, we typically have a network in the problem in our application. The network is a great source of flakiness because they are totally unreliable and rubbish. Like the minute you put an RPC into any piece of code, you have effectively broken it. We have unstable dependencies. Our databases occasionally go down. Somebody tries to rework the tables while we're mid-flow in our test. We have no idea about that. Our SMTP gateway is down. Who knows? The message queue decides it's going to start dropping things randomly. That leads to test flakiness. Who here has tested in a UAT environment that is actually really good? Right. people are laughing because UAT environments tend to be garbage. They tend to be overloaded and filled with experimental nonsense, and yet that's one of the primary places where we run tests. No wonder our tests are flaky. Well, concurrent modification of mutable state. That sounds exciting, doesn't it? What that really means is some bastard has rewritten all the contents of a database as you're trying to do things. Maybe they started their test with drop contents, drop star from contents. That's not helpful. But any change to mutable state midway through a test that's shared is guaranteed to lead to flakiness. Remote and local version mismatches. Maybe you've got protobuf version 2.x here and 3.x here. Maybe you've got one library serializing things and another version of the library deserializes it in another way. All sorts of nightmares. You need to make sure that versions match, or you do forward and backward compatibility perfectly. And I think we can skip over that last one. There are very seldom bugs in the test automation framework. Here's the thing. Flaky test can actually sometimes be a good test. I mean, flakiness happens in prod. Like, look at the things that we were talking about. Network problems, unstable dependencies, degraded environments, concurrent modification of mutable state, remote and local version mismatches. Those things all happen in production. So a flaky test is sometimes a really good test. The fact it passes sometimes indicates that when everything is perfect, everything will work. When it fails, it means that there is a piece of signal. There is something that we need to do to improve the quality of our code. Now the problem is developers. Because they will go, the test is failing, my code is perfect, I will disable the test is wrong. Have we all encountered that? I'm so sorry. I am so sorry. It is one of the worst things in the world. But sometimes a flaky test is actually a good test. But if the flaky test is sometimes a good test, why do we think they're bad? Okay, here's my hot take. A flaky test is worse than no test at all. I would prefer to not have a test rather than have one that's flaky. And the reason for that is because it destroys trust in our CI pipelines. When our CI builds fail or pass, that should mean something. It should mean something when it fails. It shouldn't mean, it does that sometimes, just rerun it. You waste time, you waste effort, you waste all the capacity of your team worrying about something, trying to figure out, is this a genuine failure? Is this an actual failure? Or worse, was that meant to have passed? I don't know. So flakiness destroys your trust in your CI pipelines, and that removes your ability to move quickly and nimbly. That is terrible. So, what we want to do, as people working in test or people who care about their builds, is we want to remove flakiness. We want to remove test flakiness. And I've been thinking about this. I have a lot of theories, by the way, so this is one of my theories I have. There are some desirable properties for systems for handling flakiness. The first is it needs to be automated. We can't have people running around doing work that machines can do. That's why we have machines. The original word robot comes from the Czech word for slave. Right? They're meant to be doing the work for us. So whatever we do, the approach taken mustn't rely on human intervention. Secondly, flaky tests are swiftly quarantined. Our CI builds have to be trusted. If we don't take flakiness out of them quickly, they will not be trusted. We need to do that swiftly. So new tests added to the build, they may be flaky. When we discover one is not how we want it to be, we take it out and we ring-fence it and we make sure it is not part of our CI anymore. But it needs to be escapable. If you have quarantined a test and it is now working, you need to be able to put that back into the general population of tests that feature as part of your CI pipeline. Seems pretty obvious, but you know, people forget this. And it needs to be transparent. If a system removes a test from CI, people need to understand why it is being taken out, and they need to be given an action item that they can follow in order to make sure that test is either fixed, deleted, or otherwise changed. Seems obvious, right? I think these are inarguable, but we're working in software, so of course we can argue about it later if you want to. And now we get on to the life cycle of a flaky test. Is anyone getting hungry, by the way?
Yes.
I love these things. In order to build a system that meets these desirable properties, we need to think about the life cycle of flaky test. Broadly speaking, there are 4 stages. The first one is to detect it. We need to spot that the test is flaky. We need to assign it. We need to give it to someone to fix. We need to resolve it. I don't care how you resolve it, just fix it, please. And then we need to verify that the test is no longer flaky. Seems fine, right? The rest of this talk is basically about that life cycle. So let's start with detection. Great. If you're using Bazel or Gradle or some of the other tools, they can find tests that have failed during build and they can rerun them. Right, so you have tests that fail there. And then you also have test logs, and test logs are brilliant because you can scrape that data and you can put it somewhere. The nice thing about test logs and scraping data and putting it somewhere is you don't need to do that as part of your CI pipeline. And that's really important because we want to give people feedback as quickly as possible. Fast feedback is a gift. Fast feedback is a gift for software. Fast feedback is also a gift for people, by the way. If you have something to say to someone, don't wait till the end of the review cycle. Take them aside, and if you've got bad news, tell them in private. If it's good news, say it in public. It's a nice thing to do. But yes, fast feedback is a gift. And by being able to process data out of band, we can do it. Do we all know what out of band means? It means sort of aside from the regular process. You've got CI running here, and you've got other things that may be lacking in processing logs. And I suggested there are different kinds of flakiness, right? So there's flakiness within a build. That's intra-build flakiness, right? And that can be done by setting a flag in your build tool of choice that will rerun flaky tests and everything is cool. There's also inter-build flakiness, where a test runs perfectly the first time, doesn't the next, passes the next, passes the next, passes the next. We've all seen that sort of blinking traffic light pattern, right? And you instantly see it in like your Jenkins pipelines or whatever it is, and you go like, that test is flaky. We know what it looks like. So, we get our test logs, we scrape them. We should store the data in queryable systems. And there's a number of reasons for that. If you're using like dvelocity by the Gradle company, I think they pronounce it develocity. I don't know, I always pronounce it dvelocity because normally dv means reduction. Why would you call the tool a reduction in velocity? But that's the name of it. Dvelocity, Datadog has this as well. They allow you to sort of spot flakiness and stuff like that. The problem is that the retention of that data may not be long enough. So you want to put that into a queryable system that you can control, where you have access to the logs and you can figure out how long you want to keep these things. That also means that you can shape the data to be exactly the shape you need for your system. And that is a powerful thing because it allows you to do some of the other things. Such as assigning a flaky test. So you have found a flaky test, one way or another. The next thing you need to do is you need to assign it. And the reason why you need to do that is because if no one owns it, no one fixes it. We've all heard of like the tragedy of the commons, right? Like where things fall apart because nobody is responsible for a thing that everyone is using and is trying to rely on. Same with flaky tests. If someone doesn't own it, it's not fixed. That's why a lot of companies like to have directly responsible individuals or DRIs in particular areas. Like it doesn't mean that person has to do the work, it just means that that person sorry, I'm not using that. That person is responsible for fixing the test and making sure it's good. The guiding light for figuring out who to assign it to is who will miss a test if it were no longer running. Now, code owners really helps in there. Code owners is a feature that ships as part of GitHub. I guess most of us are using GitHub for source control. There's nods. Is anyone not using GitHub? Absolute silence. Excellent. Good. That simplifies things. I don't have to tailor the talk for the 3 mercurial users in the world. So code owners really helped. Sometimes that's not sophisticated enough and your company will put in some other mechanism for doing it, but there'll be ownership files scattered around. A rule of thumb here is quite often those owners files go like, this team owns this failing test. That isn't good enough. You need to pick a member of that team and go, Dave owns this failing test. They are responsible for it. That's good. The other thing that we can do, because we're aggregating the data in a queryable system, is we can look for underlying patterns. Because sometimes test flakiness has nothing to do with the test. There's everything to do with the environment the test is running in. And if we spot that, like, suddenly all these tests became flaky because they couldn't make a database connection, actually we don't need to assign that test to an individual member of the team. We need to assign that test failure to the DB admins, because they are responsible for making sure their database is rock solid, and they need to make sure that thing works. That is pretty hardcore, right? Do any of you actually just give bugs to your database admin that go like, you're a root for this? No, I didn't think so. But the key thing here is that the reason why a test might be flaky might have nothing to do with the test. So, we have found our flaky test. We have assigned it to you. Now, we've got a flaky test. What are we going to do with it? How are we going to resolve it? Now, what can we do? The very first action that we should take is we should quarantine flaky tests. That means that we should disregard any further failures of this test from CI runs. And there are a couple of ways of doing this. The first way, which is really common, is just put a sort of attic moral annotation or the moral equivalent for your programming language into the test or the test method and go like, don't run this test anymore, just ignore it. If you're sophisticated, you'll do that with a link to some external bug tracking system like Jira or GitHub Issues or Linear or, I don't know, some ticketing system that you have. So you can go like, this test was ignored and this is the reason why, and so you can track these things down. The key thing here is that the test is no longer running as part of your CI. And by the way, another way to do these things, which is what we do in the Selenium project, is we just have a top-level file called .skipped tests, and we just put all the tests that we want to skip into that. And that gives us a really easy way of figuring out like what tests are we skipping and what do we need to fix when we have the time to go and fix things. It doesn't need to be an annotation. The key thing is that test is no longer in CI. It took me ages to find that phrase. We need to gatekeep new tests. So when a new test enters your system, you want that test to be rock solid. When I was working at Facebook, now Meta, before a test was allowed to be part of the CI runs, it had to run 100 times simultaneously overnight with all the other new tests. If it failed once, it wasn't allowed in CI runs. That's what I mean by gatekeeping. You're hardcore. Flakiness is not an option because it just ruins everything for everyone. Now developers might be a little bit upset about that. They have spent literally minutes asking Claude to write them a test. It's okay. You're not there to be their friend. You're there to make sure their builds are good and fast and stable. It's okay to gatekeep these things, and it's okay to explain why it isn't going into the build. If they can't figure out what they need to do, But there's another thing we can do with flaky tests, and that's just to do more retries. Let's do the maths. You've got a test that has a 2% chance of failing. You run it 100 times, it fails twice. If, when it fails, you run it again, it's got another 2%, 2% to 2%. Like it's vanishingly tiny. It trends towards 0. Now, that's great, because it means if you've got flaky tests, just rerun them. But there is a point of diminishing returns, where what you're doing when you're doing this is you're trading off the speed of your CI runs, the probability of a test passing. In my experience, a retry count of about 3 to 5, depending on the length of your test, is reasonable, and after that, it's totally unreasonable. My preference is a retry count of 1, but nobody will let me do that because they're not cruel enough. But sometimes brute force isn't wrong. It's okay to just retry things. The aim of the game here isn't to completely prevent people from putting flakiness in. It's by making sure that our CI runs, when they fail, give meaningful signal. And sometimes it's okay to rerun flaky tests in order to get that. So a common pattern with CI builds is to run all the tests. A common CI pipeline is like, I'm going to do a build. Now I'm going to run the linting checks. Now I'm going to run the, I'm going to have to be careful. Now I'm going to run the unit tests. Now I'm going to run the integration tests. Now I'm going to spin up a test environment. Now I'm going to run the end-to-end tests. And it's like, I changed a README. Why are you doing all that? You don't need to. You want to minimize the subset of the tests you run to only the tests that are affected by the changes that you have made. Modern build tools like Bazel make this trivial to identify. Ye olde worldy build tools like npm and Gradle make it harder. I think Turbo Repo has a -- affected tag that you can pass in. So if you're a JavaScript developer in a monorepo, you can also get this kind of functionality really easily. But by running the minimal subset of tests that you know are affected by a change, you can speed up your builds. And fast feedback is a gift. But what if we have something like an Android application where like loads of the stuff in the repo goes towards a sort of pinch point, like this one application, and then all of the tests depend on that thing. Like anytime you change any bit of code, all of the tests will run if what you're doing is just looking at the test dependencies. We need to do something a bit smarter here. We need to figure out how to test components in the system. And at this point, we go from complete certainty to using heuristics. We are trading off accuracy for speed. It's okay. We can do this, as Linda was saying, it's about risk management, right? Like, we can think about the risks that we're taking and decide whether or not we want to do this. It's a slide too fast. Heuristics are a trade-off. I'm trading accuracy for speed. I apologize for this photo. It is the worst one in the entire day. I feel a bit queasy looking at it. Maybe you don't. So one of the heuristics that I've seen people apply, and I'll talk about this some other time, is to look at historical coverage data. So you can go, hang on a second, when we ran this test last time, this was the area in the application that it was touched. When we ran this test, this was the application. When we ran that test, this was it. And you gather that data, and then when you make a change in this area, you can tie that back to the tests that have previously run for that. And so you can apply a heuristic and you can go like, hang on a second, by using coverage information, I can figure out a subset of tests that I can run. You can imagine far more sophisticated mechanisms, and I'll be talking about that at HUSTEF. So come along to that talk. Another thing you can do, shock horror, you don't have to keep the tests, you have to keep the thing the test was checking. You want that check to still be present, but you don't need the actual code. You can rewrite the test. We have the test pyramid for a reason. Right? And the test pyramid exists, but at the lowest level, the small tests, the unit tests, are great, because they run incredibly quickly and they're really precise. When they fail, you know the exact area that's gone wrong. Our end-to-end tests, on the other hand, are really great because they take a million years to run. They're inherently flaky, but they cover a lot of ground. That's fine. What I like to do when I identify a source of flakiness is to then drill down and write the smallest possible test that could fix that source of flakiness. Now, sometimes, quite often, that smallest possible test is a unit test, a small test. Sometimes it's an integration test or a medium test. Sometimes it is another end-to-end test, and I apologise for that. But quite often it's not. And the nice thing is, if every time you fix a bug, you do this practice of going, I will write the smallest possible test, you will end up naturally following the test period. You cannot help it. It's just an inescapable fact of writing a quality software. And the other thing is to delete it with glee. I love deleting code. I was at Facebook for just over 3 years. When I left, I ran the stats to figure out how much code I'd contributed. I had deleted in my time there 20,000 lines more than I had written. I was net negative to the number of lines of code that Facebook had, and yet they still paid me, so I was quite pleased about that. It's okay to delete things. The example that you gave earlier, where the chain tests were being run, but you didn't need to because the stuff that they tested was already tested before. That's a classic example of something that could be deleted. Right? You don't need these things, and it's okay. Do we all use source control? Right. If you delete something and you realise you've made a terrible mistake, that's okay. You can go back in time because we have source controls and it can recover things. Like, you don't need to put it in a separate directory or mark it in archive or attic or some other horrific naming convention. Just delete code, it's fine. I worked on a project once and they were told that they needed to keep the test green. And so they kept the test green. And the way they did that is they caught every exception and they ignored it. And so what I did is I started removing things. And I deleted a third of the code base before they realised what I was doing. And in the end, I went like, these are the tests of yours that were actually doing things, and everything else was noise. You can now build up from here. And I went, but it's gone forever, we'll never know what we did. It's like, allow me to show you Git. We went back in history, like, oh my gosh, you can do these things. You can do these things too. And the final stage of the life cycle of a flaky test. Flakiness is transient. Hopefully, flakiness is transient. It will be fixed. We need to figure out whether or not those tests can be put back into the general population of tests. One thing you can do, if you have like an ignore file, it's really easy just to run all those tests 100 times overnight and go like, well, it's stable now, we'll put it back into the general population. But you need some way to bring the test back into reality, into your CI runs. If you don't do that step, you might as well just delete the test the moment you mark it as flaky, because it will never go back. And it's okay. I'd rather have no test than a flaky test, so if you decide to delete the test, that's a perfectly reasonable thing to do. But you need to check that the fixes work, and when they do, you need to put those tests back because they are trying to tell you something. One really important part of this verify step is you need to make sure the environment is ready for your test to run. Like, running a test suite can effectively be a distributed denial of service attack on an under-provisioned UAT environment. Make sure it's ready for the load you're about to put on it. Make sure the databases are up, make sure the queues are up, make sure Kafka is happy, whatever it is that you're using. Like, verifying that your test environment is okay. So to recap, we want to make tests resilient to flakiness, and doing so will improve the quality of the production app. Our developers will fight you tooth and nail. They will say your test is rubbish, it's a test fault. They are wrong. Quite often they are wrong. The life cycle of a flaky test, we want to detect it. We need to do that. We can gather data out of band in order to support that. We need to assign it. When we have found a flaky test, we need to give it to someone so that they are responsible for fixing it. It cannot be a team, it must be a person. You need to resolve it. I don't care how you resolve it, it's okay to fix it, it's okay to rewrite it, it's okay to delete it. These are all perfectly reasonable options. And then you need to verify. You need to make sure that tests were flaky. Are they flaky anymore? Are they fixed? Like sometimes someone will fix an underlying systemic cause of flakiness. Suddenly a whole swathe of tests, like a bunch of them, will suddenly start working. It happens, and it's wonderful when it does. And also don't forget to check your test environments before you start running your test runs, because if the test environment is down, nothing's going to work. And that, ladies and gentlemen, is the talk, and it is approximately 30 minutes.
Yeah.
Bang on, so.
Be smart and quick, because we need to leave soon for the speaker dinner. So anyone, anyway, you can talk to him tomorrow.
Sure.
In your definition for flaky tests, by the way, love the talk, you also said that if you have a test for dependencies and that the dependencies is unstable, and your test fails, isn't that a good test?
So if the test for the dependencies fails, is that a good test? It depends. like if what you're doing is checking does the app work in a degraded environment, then yes, it's an excellent test. If what you're doing is this workflow needs to be followed accurately, then that test doesn't provide much value. So it's a real consultant's answer to go like, well, it depends, but it depends. Yeah, sometimes it's good, sometimes it's bad. One of the things that I've done before is I've had a test of the environment, and if that test fails, I don't run any of the other tests. I've seen other people group tests with tags or some other mechanism, so that if like the database is down, they can run all the tests for the message queues, and if the message queues is down, they can do the database tests. They sort of mix and match. And quite often when you do that, the pattern that you see is people go like, if you couldn't keep the test infrastructure stable, it's your fault if things are broken when it comes back up again. That's quite a challenging conversation to have, and it very seldom goes the way you want it to, but sometimes it does, and it's quite easy. Does that answer the question?
Yeah, and I'm fully on board, so.